This video is sponsored by BetterHelp. Today we're going to be looking at a very heavily requested NileBlue video. His safety video titled, Chemistry is Dangerous. Radiation is dangerous too, if you don't know what you're doing. For those of you who don't know me, I'm Tyler Folse. I'm a nuclear engineer with a little over 10 years of experience in the commercial nuclear power industry. From engineering to operations to emergency response. I don't claim to know everything there is nuclear, but I can certainly share some knowledge. Let's get right into it.
Safety is something that I've always taken very seriously, which is good because it's very important when it comes to chemistry. In all my videos, I do my best to cover the major safety measures that I take, but one big issue is that I rarely talk about the basic things like wearing goggles or a lab coat.
Safety is one of those things that is always at the forefront within the nuclear power industry and should be within any industry or when handling any sort of potentially dangerous material. And it's subcategorized, at least within nuclear, into nuclear safety, which is about protecting the health and safety of the public from radioisotopes, industrial safety, which is what Nile Red's going to be talking about, like what sort of precautions need to take in place when handling hazardous material. That would also extend to things like heat stress on the job in a hot environment, as well as things like slips, trips, and falls when using ladders, things like that. There's also operational safety, which is ensuring every component within the plant is in its proper configuration. That is to say, bumping a valve could have an effect on the system that creates something undesirable. It could be a personal safety risk, or it could even be a nuclear safety risk if you manipulate a component that you shouldn't have. For instance, the valves for the auxiliary feed water system were inadvertently left closed just before the 3 Mile Island accident. And while that wasn't the root cause of the accident, if those valves were open like they should have been, nobody would have talked about 3 Mile Island because that would have mitigated the issue before things would have gotten a lot worse.
Kind of okay in the beginning of the channel because my audience was mostly chemists. However, the channel has grown a lot, and that just isn't the case anymore. So I've decided to make a proper video dedicated to safety when it comes to chemistry.
Good disclaimer.
Which I think is a long time overdue. I think that chemistry is one of the most exciting branches of applied science, but in my opinion, it's also one of the most dangerous. It can involve almost every hazard possible, from fire to explosions, to poisons or toxic gases. If you don't know what you're doing, and, well, even if you do know what you're doing, accidents are going to happen. The main difference, though, is that if you're prepared, you can make them happen a lot less often, and when they do happen, they're way less severe.
Yeah, and there's so many indirect effects as well. I mentioned the fires of explosion. There's just it could be the whole shock value. You see, something combust when you're not expecting it. It could freak you out, and then you run into something, or while you're handling something else that's hazardous, like an acid spilling on yourself, or just something sharp and you drop it just because something freaks you out. There's a lot of indirect effects. And plus, some of these hazards could have an effect on your mental health even. Mental health is such an important and often underrated aspect of safety and wellness. This brings us to our sponsor, BetterHelp. BetterHelp makes starting therapy easier and much less intimidating for a lot of people. You can pick phone calls, video chat, or even messaging, whatever is more comfortable for you. BetterHelp can match you with one of over 30,000 therapists within their network based on your needs, preferences, and location. You get to pick a time that is convenient for you. And if you feel like your therapist isn't a great fit, you can switch therapists with a push of a button at no additional cost. Join over 4 million people who have used BetterHelp to start living a healthier, happier life. Click the link below in the description or visit betterhelp.com/nuclear. Clicking that link helps support the channel and also gets you 10% off your first month of BetterHelp so you can connect with a therapist and see if that helps you.
I've been doing chemistry for years, and I have had many accidents, but because I took basic safety measures, none of them have been serious. Besides minor cuts from broken glass or something, I've never had a major injury, and no one around me has been injured either.
That's good.
When it comes to basic safety, there are many aspects, and the lowest level of it is just what you're wearing. The proper term for this is personal protective equipment, or PPE, and the most common form of this are gloves, goggles, and a lab coat.
Gloves, goggles, and a lab coat actually go a pretty long way for radiation protection as well. There are some, like a basic radiation area, not a contaminated area, mind you. One common misconception is the difference between radiation and contamination. Radiation is you're just near a radioactive source. Something is decaying and imparting energy somewhere. That's not means it's contaminated, because it could be completely clean. Contamination is when there is stuff on the ground that can spread. You need additional precautions to ensure the contamination is confined to the contaminated area. But for just a radiation area, that's enough. I mean, typically people wear hard hats, but that's not for the radiation. It's because the radiation area is also just part of the nuclear plant. The contaminated area is where you'd wear the protective clothing just to minimize the spread, similar to what people wear in a semiconductor factory. Another common misconception is the protective clothing you wear in a contaminated area is designed to protect you from radiation. It prevents the spread of contamination. You wear a similar sort of stuff in a semiconductor factory, for instance. And yeah, it'll protect you from alpha particles, but so will your regular clothes. And in many radiation areas that are not contaminated, it isn't required.
It's used to protect the eyes, which are the most vulnerable part of you. There are many commonly used chemicals, like acids, that can easily and quickly blind you, or at least permanently ruin your vision. Goggles are the most important barrier to this, and I've personally had my eyes saved by them at least a couple times.
So that is your basic sort of safety glasses that you would wear for traversing the plant. In certain areas like the condensate polishing system, where there's a lot of hazardous chemicals, a requirement there is to wear these goggles over those safety glasses just to provide that additional layer of protection. And you can see these surround your eyeballs more just to prevent any of the acid or caustic, mainly caustic, from getting in your eyes.
Also, most of the time that you get something in your eye, it's because something splashed or popped and it was completely unexpected. Yeah. So for this reason, you just need to always wear goggles by default the moment that you enter the lab, even if there doesn't seem like there's anything going on.
And the main reason why you need those other goggles is because of the splash and get around the corners. Those safety glasses that he was holding, there's still a little bit of an open spot where stuff can get in your eyes or on the skin by your eyes that can, potentially get into your eyelids and then in your eyes. The point is, it's just an additional layer of protection. And like anything, you just need to be aware of the hazards and the potential hazards in the area when you discuss on your job safety plan as far as what you need. Obviously, if you're dealing with hazardous chemicals, but it's going to be in a totally enclosed, no splash risk whatsoever, like the risk is completely engineered out because it's all within enclosed piping, then yeah, regular safety glasses are probably good enough. And this brings me to my next point. So now Red immediately started talking about PPE. Well, that's actually the least effective means of safety control, according to the Center for Disease Control's hierarchy of controls. Elimination would be the first option. So in the case of, say, you're working with a chemical that has a respiratory hazard, determine if you even need that to begin with. If you don't, just get rid of it. And if you're unable to eliminate it, you substitute it. See if you can substitute that chemical with something that's a bit safe, that's less of a hazard. So talking about that same respiratory hazard would be to install fans and a better ventilation system to remove the hazard that way. And then you get into administrative controls, which I would say once you get to this point, you're getting into the way less effective because this implies that people have to follow the rules. And in the case of respiratory would be enforcing breaks, limiting exposure to say 5 minutes, 10 minutes, whatever the industrial hygienist determines to be safe, and kind of filter people in and out That's actually one way that a lot of that during the cleanup after Chernobyl, a lot of the liquidators were regulated because they couldn't remove the hazard. They couldn't even really control it, but they had a lot of people and they could give people time limits because minimizing your time in front of the hazard, one of the ways to reduce radiation dose. The others would be distance and shielding, but again, they didn't really have those options available to them based on the nature of the accident. But again, you're dependent on people following the rules or having to put in an oversight plan through the work supervisor or work foreman. And the final one is PPE, which NileRed talked about. And again, in the respiratory hazard would be to wear a respirator or even something as simple as an N95 mask, just to, again, it all depends on what the hazard is for what the appropriate PPE is for the job. But I just thought I'd bring up that PPE is really your last ditch effort to protect people from the hazard.
Lesson when I was a lab tech about 6 years ago, when I was cleaning up hours after the students had left. There were just a couple things left over, and one of these things was a used pipette with a bulb that was still on the end. Students would always forget these, and every day I had to clean them up. For whatever reason, though, this time I tried to take off this bulb, and I don't even know how it happened, but I ended up flicking the contents of the pipette all over my face.
Ooh.
It was a mixture of strong acids, and it immediately started burning everywhere.
The other hazard associated with flicking is it's a very thin tipped item. You could, inadvertently stab yourself in the face with something like that. That's another reason for eye protection, in addition to chemical hazards, just physical hazards, sharp objects hazards.
Except where I had my goggles. I then quickly ran over to the sink, and I washed my face with a lot of water, and I was fine. This all happened really quickly, though, and it was completely unexpected, and it taught me how important goggles were.
Yeah.
Since then, I've only splashed something on my face, I think once, and again, it was fine because I was wearing
sodium
goggles.
hydroxide, that's
Also,
caustic.
Your own clumsiness isn't the only thing you have to be careful of, and goggles become even more important when you're working around others. In both my accidents, no one was next to me, but if they were, it might have hit them as well. So, it's important to be protected both from your own mistakes and from those made by others. Sometimes, even when you're wearing goggles.
One other important thing is a lot of chem techs I've seen, in addition to plant operators, maintenance technicians, I usually see them working in pairs, and part of it is just so they can look out for each other, remind each other on which PPE to be safe. And plus, one of them can look at them to make sure that that they have positive control of the instrument they are manipulating, being the pipette in this case. There's no other immediate hazard that they could potentially. Really, it's just a matter of looking out for each other. Now, that isn't required except for some specific jobs. It really just comes down to, again, your job safety briefing. That is one other thing that could be used. But this buddy system would qualify as an administrative control on the hierarchy of controls.
You're wearing goggles, chemicals can still get around them, especially if there's a large spill. Or you can also just make a mistake. For example, again as a lab tech, I once saw a student take them off just for a second or something, I think to readjust them, and coincidentally get splashed at the exact same time. Because of this, there's also another layer of safety
that's a real thing, because when you're making an adjustment, your focus is off of whatever it is you were doing. It's no coincidence.
Important, and this is a proper eye wash station. This makes it possible to continuously flush the eyes with water,
and having
one can be the difference between permanent eye damage and being perfectly fine. In most cases, the damage to the eyes is directly dependent on how long it takes to wash out the chemicals.
I've never had to use one of these personally, but the instructions are to wash for 15 minutes. And while that's uncomfortable, it beats permanent eye damage.
Eye wash lets you hold open both eyes and flush them continuously, and you usually want to do this for at least something like 15 minutes.
Yep.
Out of curiosity, I've tried washing my eyes with a standard downward-facing tap, and it's almost useless in comparison. In an absolute emergency, maybe one of those removable taps might work for one eye, or a bathroom shower could work for both, but both those options are really far from ideal. With all that being said, though, the main point...
I mean, yeah, I could see it being better than nothing, but the eye wash stations are designed for that specific purpose and meet the emergency use criteria. There's a requirement to test them to make sure they work with a certain periodicity, definitely at nuclear plants and really at any site that uses them, because it's per the manufacturer's recommendation. That's something that I know plant operators routinely do on rounds in their buildings for both the emergency eye wash stations and the emergency showers. Because they're designed to act on a dime, because it's designed to be able to, you're going to be disoriented with whatever got splashed in your eyes, that you can fumble around and just push down and it gives you the full spray, the full effect. I can only imagine trying to fumble with a sink or a shower while you got something in your eyes.
Is that eye protection is absolutely necessary the moment you enter a lab, and there's really no exception to this. The only variable is the level of protection, where sometimes just a pair of prescription glasses can be okay. As long as they're big enough, they generally offer enough protection from small splashes, like the one that happened to me. They don't, however, properly cover the sides, and liquids can still get around them. So, I only use these glasses when I'm doing something that has pretty much zero risk of splashing. For example, in a video that I posted a little while ago on this channel, I wore my regular glasses because all I was doing was burning some tablets on a camping stove. If, however, I at any point had to use acids or even just a solvent, or if I had to touch a dirty pipette, I would have put on my proper safety goggles. In theory, it's also possible to buy these clip-on shield things that go on the sides and below prescription glasses, but I find them kind of pointless. It's so much easier just to find a decent pair of safety goggles that are able to go over and completely cover the glasses.
It's actually the exact brand that I have. I normally wear contacts, but a lot of times, especially when I worked back shift in the nuclear power plant, would wear glasses, because there are times where it can be kind of hard to keep your eyes open for that long. So that's why I got glasses that are just like that.
In my opinion, this idea of adapting the safety equipment to the particular project or environment is the best way to do things. I find that it's a lot safer because it means that I'm taking a much more active approach, and I'm constantly evaluating the danger of what I'm doing or what I will do. However, if you try doing that without enough experience, you could be actually putting yourself in danger. So when just starting with chemistry, it's very important to do everything by the book.
There is also another extreme, and that's wearing too much PPE that it becomes an increased hazard. And the classic radiological example of this is the respirator problem. So a respirator would be used to protect you from internal dose. Radiation dose is far more hazardous to you if it's inside the body compared to, say, surface contamination. So if there's airborne contamination, particulates that could get inside you and give you dose, then a respirator may be warranted. But it all depends on the briefing, and you have to know what the dose rate is and how long you're going to be there. Let's say the dose rate is 50 microsieverts per hour, and the job takes 3 hours with a respirator. And the respirator can reduce your dose in the area by a factor of 2. So your expected dose is 75 microsieverts. However, due to the nature of the job, there's a lot of bending and getting up underneath pipes and stuff like that. What if the job could be done in only 1 hour without wearing a respirator? Your dose rate would be twice as high, but you're only going to be there 1/3 of the time. So your expected dose would just be a mere 50 microsieverts. In that specific scenario, you're better off not wearing a respirator. Again, it's very scenario dependent, so get a second look and get better at your estimates for the hazard and how long you're in front of the hazard, because in that particular example, the PPE is actually putting you in front of more danger just because you're going to be there for a lot longer. And that's neglecting the effect of it being annoying and being a 3-hour job, so you're going to be a little more anxious to get it done. You can't see as well in a respirator because it's going to fog up. Just something to consider. More PPE does not always mean more better.
Always wearing the classic PPE combo of proper goggles, gloves, and a lab coat. For gloves, the most common ones are made of either nitrile or latex, but nitrile is usually better because a lot of people have allergies to latex.
That's true.
When using gloves, though, they don't just magically make everything safer, and there are still a bunch of safety precautions that need to be taken. For example, they protect your hands, but they're also a very easy way to contaminate other things. So it's important to never leave a lab if you're still wearing gloves, or to touch things like a phone, your face, or clothing.
There's a certain way to take your gloves off. You reach under your gloves because the inside of the glove is not contaminated, just the outside. With one hand, you take its glove off, and then while you still have it on your fingertips, you take the other glove off, and then you do this all immediately over the glove disposal, which if it's radiological contaminated becomes a thing of low-level waste, which can then still be cleaned on site. And there are entire classes on protective clothing that you have to take before working in a radiological controlled area, so you know how to put on and take off all of your PPE, including gloves.
It's also important to take the gloves off after they've been contaminated because they don't offer unlimited protection. A lot of chemicals are able to soak through them, and just leaving them on would make wearing them kind of useless.
Depending on the job, you may wear multiple layers.
Is also something to pay attention to, because if it's not done properly, it's pretty easy to accidentally touch your skin and to get chemicals on it. So the proper way is to first pinch the glove like this.
Oh, here he is. He's showing what I just said.
Pull it off, and then with your clean hand, you can now put it under the glove and pull that one off. And
okay, he's showing that's not the thing. Yeah, in some of the training videos, I've seen it somewhere where you'd still have some of the one glove off. Again, just whatever offers for a little bit better control. There's a few different ways to do this, but the point is, don't contaminate yourself.
For most basic work, I just use these nitrile gloves, but it's always important to be aware of what the glove material is compatible with. For example, in a video that I made a while ago about nitric acid, I showed that when it's pure, it can light nitrile on fire.
That's
I also
cool.
showed that it didn't react or do much to skin, so in this case, it was safer to not use any gloves at all. Now that's interesting,
I didn't know about this.
However, there are other materials, like some vinyl gloves, that I could have safely worn.
Yeah.
With enough time, most chemicals and solvents will eventually make it through a glove, but some of them can easily penetrate certain glove materials, and it means that depending on what you're using, it might not actually be doing very much.
Yeah, these charts are commonly posted in pertinent areas of the plant. Here's one with gloves. There are ones with certain electrical safety equipment, like what sort of suit you need for a certain arc rating, and as well as for radiological stuff. This is really bringing back some memories watching this.
So again, it's important to make sure that the glove that's being used is appropriate for the work that's being done. Now, the last thing in the classic PPE combo is the lab coat and clothing in general. The lab coat is a good way to protect the arms, and it also just stops chemicals from getting on clothing and then you leaving the lab with them on you. It also just protects clothing in general because a lot of chemicals, especially acids and bases, tend to make holes and can destroy whatever you're wearing.
There are some cases where, in even some lightly contaminated areas, where a lab coat is enough. Like, you don't need the full protective clothing suit that I showed earlier. But in a lot of cases, I've seen people wear the full protective coveralls more so than a lab coat. Main places where I see lab coat is in the on-site chemistry labs, appropriately enough.
Lab coats are also usually more resistant to fire and chemicals, and if there's an emergency, they can be taken off much quicker. This is important because if, for example, you were wearing a t-shirt and then you spilled acid all over yourself, to take the shirt off, you'd have to pull it up over your face, which isn't ideal.
I've seen some where people got contaminated through there, and yeah, they don't let you take the shirt off that way. They're just going to destroy the shirt, depending on the level of contamination. They'll just get out a pair of scissors and cut it off.
Or if you were on fire, I would just say good luck even getting the t-shirt off. A lab coat, however, can just be taken off in seconds, and you don't have to wipe it over your face to do it. The one that I'm using in particular has these buttons, but I'm not the biggest fan of this, and I much prefer the variety that use those snap-on things that you can just pull and instantly take them all off. For most cases, the buttons are fine, but in an emergency, especially if you're panicking, you might fumble with the buttons, and it could be a problem. In the case of an absolutely massive spill, the lab coat probably won't be able to stop everything. This is why, like with the goggles, there's usually a second measure in place, and this is an emergency shower. When the handle is pulled, it dumps a lot of water, and you can wash your entire body and strip off all the contaminated clothing at the same time.
Those are usually right next to eye wash stations. In some cases, I've seen them combined into effectively one unit. So you could eye wash an emergency shower at the same time.
Most lab coats are made of a mixture of polyester and cotton, which offer good protection for most general lab work. However, they aren't great when working with a lot of fire because polyester and cotton are themselves flammable. Several years ago, though, some combination coats started to become available, and I decided to buy some to replace my old crappy ones, like this one here, which I really hate. These new ones are way fancier, and they even offer liquid resistance, so when things hit it, it just beads up and rolls right off.
That's a nice thing to have.
In my opinion, they also just look way better, and they also have these wristbands so that you don't just have a dangling sleeve that will collect and soak up chemicals off the table, and they have these snap-on buttons that I was talking about, so they're way easier to pop off, and you don't get stuck with all those buttons. It also goes much higher than a lot of typical lab coats, meaning that you get protection obviously all the way up to your neck, but that really depends on what you're doing.
And things like comfort and being able to easily pop stuff on and off is a big help for any sort of PPE. Just like the respirator example I used earlier. Uncomfortable PPE, well, that's just going to be another reason for you to rationalize not using it.
The only issue with them is, well, cost. And this one was almost 10 times more expensive than the regular one.
Yeah.
In my opinion, it was worth it, but it's pretty hard.
Fire and liquid resistance.
It's also pretty hard to justify paying that much. Again, though, with all that being said, the main point is that like goggles and gloves, lab coats are also an active measure. So before and during each project, I'm always thinking about what is appropriate to be wearing. For example, again in that video that I mentioned earlier, I wasn't wearing a lab coat. However, this wasn't just negligence or something, and it was because I just didn't need one for what I was doing. There was zero risk of splashing, and what I was making was almost the same as wood ash.
That looks so cool. But yeah, just like with anything else, don't go PPE crazy just for the sake of wearing PPE. You need to just dress for each of the individual hazards, just like you do with the gloves and the goggles and the protective clothing in a radiological controlled area.
And it was completely non-toxic. One thing to keep in mind, though, is that the ability to go completely without a coat is a bit unique to my situation. This is because I'm the only person that works in this area. If it were a shared space with other people, that was not something that I could have done. Also, it was one of the few projects that I've ever done that a lab coat just wasn't needed for, and in other projects, you are almost definitely going to see me with one. Now, besides a lab coat, and in terms of clothing and attire in general, there are a few fundamental rules. Just like any industrial workplace, you can't just wear something like sandals, and the feet have to be fully covered. This is mostly to protect them from chemical spills or splashes, but it also protects them a bit if you were to accidentally drop something like a hot plate. It's also important.
Don't recommend trying that. At the nuclear plant I worked at, it was totally enclosed, leather uppers, not necessarily steel toes or safety shoes. Moving away from just steel, because steel toes are very uncomfortable, and a little more flexible materials like aluminum can still provide protection. And again, it depends on what the hazards are and what the risks are. But I've never actually had to wear steel-toed boots, but that's partially because I never in an area that required the use of them. That being said, you can't wear anything like sneakers, especially those ones with a little bit of holes in them to give your feet a little bit more comfort when it's hot and breezy to allow heat to be removed. Well, that's just going to let air and other stuff in and doesn't provide you any protection or support for either its dropping hazard, just walking on uneven terrain and getting it stuck. Impact and compression is what safety shoes are designed to protect against.
Completely cover the legs, and to never wear something like shorts. This is because the lab coat doesn't go all the way to the ground, and you need to protect your legs from spills and splashes.
Yeah, no one would ever wear shorts at the nuclear plant. Even for just traversing, you could wear short sleeve shirts if you weren't going into any hazardous areas for just walking around, but you couldn't wear shorts. You had to wear some form of pants or trousers.
For this reason, I actually have a pair of work pants that I keep in the lab, just like the lab coat. Both these pants and the lab coat also get washed often to make sure that they don't just become full of chemicals.
Yeah.
But anyway, with all that being said, these are just some of the basic guidelines to follow.
One thing with the protective clothing from earlier, I'll often see people wear scrubs, not unlike what you see doctors and nurses wear underneath them. And that's mainly because they're more comfortable. The external coveralls and hoods aren't exactly designed for comfort in mind, but supposed to wear stuff underneath them, and typically scrubs with undershirt and underwear underneath just gives you that additional layer. Plus, it's just more comfortable and relatively light for wearing these sort of coveralls. There are some highly contaminated areas where you actually wear 2 layers of these coveralls. So it's important to dress somewhat light underneath them, because even during an outage, being inside the reactor containment building can get fairly hot. I'm not talking like 130 degrees, like right next to the main condenser. That's 130 degrees Fahrenheit. But in the upwards of 80 to 90 degrees, which is still pretty hot, especially if you're going to be working in there for a while.
For experience, projects tend to get more complicated and dangerous, and different PPE and protocols are usually required. For example, for some things, it might be necessary to wear a full face shield, specific gloves, or specialized goggles. So again,
now face shields you very seldom see worn other than for specific task-related stuff like welding, for instance. And of course, those are completely walled off and can only be done with a hot work permit. But face shields, as far as radiation protection, don't really see them anymore. I had an incident where one of them actually fell off down into the reactor cavity, because during an outage, the unit is defueled and flooded up with water, because water's still used to minimize dose when you move the fuel from the reactor vessel to the spent fuel pool. And so it's all flooded up with water, and then a face shield fell off, got sucked in to the residual heat removal pump that removes decay heat, and ended up breaking the pump. Now, there wasn't any nuclear safety at risk because we still had 2 more residual heat removal pumps, but it really extended the outage because you need all 3 in order to start up. They won't let you start up without having those additional trains of RHR pumps. That's one of the reasons why we don't use face shields. And that type of event is what's called a foreign material exclusion, or FME event. That was a complete mess. And we had to overhaul our FME program in order to ensure things like that don't happen again, which we did. And part of that was no more face shields. Use different types of PPE that isn't something that can fall off.
Approach must be taken for each new project or task. Now, as I mentioned earlier, PPE is just the base layer, and it offers a foundation of safety. Arguably the most important part, though, is the next layer, which is research. To avoid accidents or injuries, you fundamentally need to know what you're doing and all the risks that are involved.
100% agree. Because the PPE, if you don't research, then the PPE is essentially useless to you because you're not really sure what it's for. And part of it is researching the hazard and knowing how. The other part would be just knowing how to wear the PPE for a given hazard.
For any project, I make sure that I know the properties and all the dangers of every chemical
Remember this
that I'm
from
using
hazmat training?
and all the possible reactions that they might have. One of the most common mistakes is to accidentally mix some incompatible chemicals or to mix them improperly. Some of these mistakes are more commonly known, like adding water directly to a concentrated acid. It can create enough heat to violently boil and splash stuff everywhere.
I've heard of this sort of thing happen, and a lot of it is as simple as either working too fast and reading the label wrong, or working with chemicals that aren't properly labeled. So you're not ahead of time knowing that it's incompatible because you're not sure what. If you're not sure what it is, then don't use it. Have a specialist come over and verify what it actually is. And another reason for peer checking is so your buddy can help make sure and give you that little reality check to know how this chemical interacts and to verify that you're using the right chemical. Because a lot of different chemicals can look the same, just some aqueous solution that looks just like a jug of water, but it's not.
When it's done the other way, so acid to water, it still generates a lot of heat and it needs to be done slowly, but it's much easier to control. The less commonly known errors, though, come from accidentally mixing together incompatible chemicals. This is a list of all the common incompatibilities that I pulled from the ACS website, and it shows the major ones to look out for.
Yep.
All the chemicals involved here are common lab chemicals, and if they're mixed, they can either react violently, become explosive, or generate toxic or poisonous gas. What I find interesting is that a lot of these combinations are able to be done safely, and they are sometimes done purposely.
It's interesting that I wasn't aware there was a common list of things you shouldn't mix together. I'm used to the material safety data sheet. So like given a chemical like sodium hydroxide, it gives you several pages of information that includes what it doesn't play well with, what the fire diamond hazard is. And by fire diamond, I mean NFPA safety diamond that tells you what all the hazards is. You've probably seen many of these before. Also, if you're interested in seeing my reaction to another video that involves to a very hilarious explanation of fire diamonds, I'll add that down in the description.
For example, for some chemical reactions, you need to combine sodium with alcohols, and I've done this a couple times on the channel. I also made a video where I combined sulfuric acid with potassium permanganate to make the really unstable manganese heptoxide.
Wow. Just a drop. I haven't seen that video yet.
So, it's not that you can never combine these chemicals ever, it's that you just have to know what you're doing and be prepared to handle the reaction that will happen. It's only when it's accidental and you don't expect it that it starts becoming dangerous. It's also really not uncommon to hear about lab accidents.
That's exactly it, and that's the same truth with nuclear power. It's only dangerous if it's unexpected and you don't have a plan for it. It's really just about having the amount of respect and caution for any hazardous source of energy, whether it be chemical, heat, pressure, or radiation.
That were caused by mixing incompatible chemicals. It even happens in university research labs and in industry where people have been trained and they're supposed to know what they're doing. So before working on anything, I do a lot of research to know exactly how everything interacts and what could go wrong. For example, could it explode? Is there a risk of it bubbling out of the flask? Could it light on fire? What if it spills? How would I clean it up? What if it gets on me? What safety protocols do I have set up for that? Even things like, what if the power goes out and I have no light or my fume hood stops working?
Those are the exact questions. So he's going through, and this is an important part of a job safety brief. the what could possibly go wrong section, or your contingency section. And him bringing up what if we lost power is great, because that's something that is brought up a lot in nuclear power plant style briefings. The main things that I would add to that for a nuclear plant would be, how does what we do affect reactivity, which means does it affect the core? In a lot of cases, the answer is no, but there are some cases, at least in the pressurized water reactor that I worked at, that anything that affects steam flow affects reactor power. Now, typically not by very much, but reactor power follows steam demand, which means if you raise turbine load, and what that physically is you're opening up the governor valves ever so slightly more on the main turbine, reactor power is going to go up. So if you're doing maintenance or making an adjustment to one of the steam glands on the turbine, it affects reactor power a little bit. And basically what that looks like is really just going to be an increased monitoring plan for the primary reactor operator, the one who physically drives the reactor, and the plant operator that's making adjustment to the turbine gland. You typically don't see very much, but it's important to discuss contingencies, like what if it results in a steam leak and reactor power goes up? Well, the primary reactor operator just needs to be ready to lower power in order to compensate. Note that anything out there wouldn't approach dangerous levels.
Then, after I think about all this, I take all the precautions to deal with all these possible issues.
Yep.
My general approach is to assume that the absolute worst thing will happen, and to only start if I feel that I'm prepared to deal with it. If I don't
for the
feel
worst and
comfortable
hope for the
dealing
best.
with the worst possible scenario, then it's not something that I should be doing.
Exactly.
This is not only for my own personal safety, but also for the people around me as well.
Everyone at the nuclear power plant has stop work authority, and it's taken very seriously.
My worst case scenario at all involves potentially harming someone else, then the project is completely canceled. Now, the last layer is a mix of smaller things, but they're all still very important. The first of these is waste management, because every project will produce some sort of waste that has to be dealt with. A lot of can't just be thrown out, and they're horrible to both the environment and wildlife if they're just poured down the drain. There's a large responsibility.
What this looks like is both for chemical waste and for nuclear waste, for that matter. There's a whole massive flow chart and like different sort of bins of where you put everything on what can be thrown away safely, what can be recycled, what you have to do a little bit more to it to be recycled. In the case of radioactive waste, some of it is just a matter of it needs to sit for a bit to decay away before being disposed of. And I'm talking about spent resins from, say, a reactor coolant purification loop. Spent fuel is a whole different animal, and I've discussed it a lot more in other videos. But there, it's about long-term storage in the form of dry casks.
Handle and dispose of waste, and if you can't do it, then you shouldn't be doing chemistry. I'm not working at a university or something, so I have to personally deal with it. This in itself is a whole process, and it takes a lot of time and effort to do. What I usually do, though, is convert my waste to a form that is less reactive or toxic, and then put it into storage. Over the years, I haven't actually made very much of it, but I will eventually have to pay a company to have it taken away. Another very important thing is how the chemicals are stored. Every chemical has different properties, and everything needs to be organized in a way to minimize the risk of a reaction. The
reminds me of all my
is to
hazmat
separate
training
things
again.
like acids from bases and oxidizers from reducers, and to keep them in completely separate areas. Flammables are also kept separate, and some highly volatile or unstable things are kept in a fridge. The fridge also has to be a specialized explosion-proof fridge that won't ignite any of the vapors when it tries to turn on. There have been many stories of fumes building up in just...
It's just really cool that he has all of this, like he's not in a part of a plant or a university or something like that. He went out and got all this stuff. That's something that I've never really had to go do. I've more of just handed it off to like my industrial safety department, for instance, in terms of where they would procure like the safety fridges and the rated safety cabinets and all that. It's very interesting.
Fridges, and then when it turned on, it ended up detonating. I could
Wow.
keep going on like this for a while, but the main point is that you can't just throw all the chemicals together in the same cabinet or something and assume that it would all be fine. Even if things
Yeah.
are stored optimally, though, all the chemicals still need to be checked on frequently to make sure that they aren't either leaking or degrading.
If you make a mistake and inadvertently put some non-hazardous waste into a hazardous waste drum, well, guess what? That's all considered hazardous waste now. So not only is it a bad practice just in terms of a chemically reactivity perspective, but you're just creating a lot more waste. It's going to create a lot more processing, and it's going to get more expensive for the off-site shipment and disposal. It's just a mess. You're creating so much more work as well as a hazard.
For example, some common solvents like diethyl ether or THF have a tendency to naturally form explosive peroxides. For this reason, they're usually stabilized with something to prevent this, but even then, they have to be monitored.
Yeah.
Over time, even if it is stabilized, peroxides can start to build up, and then if the solvent is evaporated, it can cause them to detonate.
That's something I didn't know.
Like I said before about
Not
incompatible
an expert on
chemicals,
peroxides,
it's
though.
not uncommon to hear stories about this happening and causing an explosion. Also, the worst part about chemistry is that because everything's done in glassware, all the explosions involve
Broken
a lot
glass.
of glass shrapnel. And now the last
A
thing
frag
is just
grenade, basically.
behavioral, and there are a lot of miscellaneous rules. The first is to be very careful about working alone and to inform those around you what you're doing. There have been many sad cases of people getting injured or killed because they were working alone.
Yeah, because no one's able to rescue you is one aspect. In addition to just the increased odds of you making a mistake without a peer checker.
Doesn't mean that you can never work alone, though, and it just means that you need to carefully assess the danger of what you're doing and know if it's okay to do on your own. Some things are totally fine to do, but sometimes you need to have other people around you who are able to help if there ever is an emergency. These people should also be briefed with all the safety protocols and know exactly where to find things like the fire extinguishers or the
And
eye
what
wash
type of fire
station,
extinguisher
because
to
if you've got
use.
something like acid in your eyes, you might not be able to see. Also, when you're in the lab, you should act as though every surface is contaminated. So, the moment you touch pretty much anything, you are no longer able to touch your face, your phone, or your clothing in general. You should never eat in the lab either, or bring in any form of food.
That's true with radiological hazards too, because internal dose is so much worse. The last thing you want to do is eat or drink. One contingency that is prepared for at nuclear plants in the event of a release, there will be an announcement made that it wouldn't be no longer safe to eat or drink in the vicinity of the release.
Everyone has made the mistake of being distracted and then drinking from the wrong cup. And I don't really think I have to explain why that would be a problem.
Oh, wow.
Also, food would just get contaminated in general, and this is the easiest way to spice your food with chemicals.
It could also
But
contaminate
finally,
the experiment.
with all of that being said, I think that I covered most of the basic safety things when it comes to chemistry. However, I do want to be clear that this was not at all comprehensive, and there's still a lot of stuff that I didn't include. Also, knowing these basic rules isn't going to be enough to just jump into doing chemistry, especially
Many
as an
safety
amateur or
classes
hobbyist.
need to be taken.
Before starting the Nile Red channel, I had years of experience as a science student and then as a lab tech and a grad student before I even attempted it on my own.
Okay, that all makes more sense. He's done a lot of extensive lab tech experience. Because I've noticed a different layer of safety compared to him and some of these other YouTubers that I've done reaction videos to. His safety approach clearly showed an increased layer of training or not that, say, Electroboom and Styropyro aren't qualified. That's not what I'm saying at all. They're very qualified and they are definitely subject matter experts. But part of it is some of them they included as part of their channel. Some of the goofiness. Nile Red's channel seems very much like it incorporates a lot of the by the book safety stuff. It just shows a different background is all I'm really trying to say. All of which are great channels, and I've thoroughly enjoyed watching all of their videos.
And even After all that, I feel like I was just barely competent enough to do it safely. This is because to do it yourself, you not only need to know
Bare
all
minimum
the safety
confidence is the
protocols,
best you'll ever be.
but also how to set them up properly. This
Had
isn't
an
to say,
instructor
though,
say that.
that it's absolutely impossible to do chemistry on your own at home. There are a lot of projects that are totally fine to do because they only need basic PPE and they don't produce any waste that's difficult to deal with. Some examples of this might be things like extracting DNA from strawberries, the iodine clock reactions, or growing tin crystals. However, there are a lot of projects, probably most of the ones that are on my channel,
that one's pretty crazy,
that would be a lot harder to do safely and responsibly. For example, distillations of things like mercury metal or sulfuric acid are insanely dangerous, and just wearing standard PPE and thinking
plus you're
it's
dealing
all
with
gonna
just
be
the
fine
distillation process by
is a
itself.
recipe for disaster. This is one major reason why amateur or hobbyist chemistry has always concerned me a bit, especially because it's something that is implicitly promoted by my videos. I genuinely believe, though, that without some form of proper training, it's just not possible to safely do a lot of it. Chemistry is fun and exciting, but there is a very real danger to it, and that can never be overlooked.
Well said. Same with radiological processes. So at the plant I worked at, the safety training by itself takes several days of classroom and practical training. And that's just the safety training, let alone like some of these individual tasks and experiments that NileRed mentioned. You would have to be qualified on certain tasks. First, you would have to be trained on it, get it signed off, and then you're evaluated that you can do the task safely with someone evaluating you, following you around with a clipboard to say you can do this particular task. And that's after you've done all of the basic safety and sort of everyday chemistry tasks, like being able to take a water sample from the secondary, for instance. But then there's certain tasks, like some of this, the equivalent of some of the stuff that NileRed does, that requires a completely separate certification for you to do this task and for you to do it independently. And in the nuclear plant, very rarely see anything done independently. Maybe something simple like, again, taking a sample for a chemistry tech. Ultimately, in order to be fully qualified, we're talking weeks to months of safety training and specific task training, plus times, being on shift, learning what routines are, that sort of thing, before you're capable of standing watch by yourself. When I say by yourself, I mean like not under the instruction of, say, a journeyman technician. No, I'm afraid watching a few YouTube videos isn't going to get you qualified by itself, but it certainly does a glimpse, and I'm really glad NileRed, or I guess I should say NileBlue, I know it's the same person, did this to just give you just to give us all a little bit of an insight of how seriously he takes safety and how it's important for whether doing house in chemistry or really any sort of activity. All the safety training I've had at the nuclear plant has affected stuff I do around the house. I really appreciate the recommendation for this video. Thanks again to BetterHelp for sponsoring this video. Again, the link is betterhelp.com/nuclear. And thanks again for watching. I'll see you next time.